Hello everybody, welcome back to the channel. This is Michael, KE4EST. And today on the workbench, I've got a HP model 410B VTVM, or vacuum tube voltmeter. And this model came out in the mid to late 50s. It was real popular through the 60s. And it's still really popular with people even today. Some people regard this as the Cadillac of vacuum tube voltmeters, mainly because it's well designed and the way it's made, and because it's got such a flat frequency response all the way up to 700 megacycles or megahertz, what you'd use today, megacycles. And some says you can even use it up to over a gigahertz with no problems. You'll have a drop off a little bit, on the frequency response. Probably, I'd say, time you get up there, you're down 3 or more dB, but it's still usable. And that's mainly the reason I'm going to restore this and use it. I bought this, I think back around January or February. I come across it and had a good deal on it. I've been looking at these for a while and looking for one similar to it. Come across a good deal on this one. You can see it's pretty good shape. So I just couldn't pass it up, and mainly because mainly what I'm gonna use it for is I want something that's I can use for it's got an RF probe or AC. This probe here is for your AC, and it's got just take a regular banana plug and plug in there with the clip for your ground. This has got a little tube inside of it. So you're doing work, say an HF transceiver, HF rig. A lot of those, when you go to do an alignment on them, it'll say required AC millivoltmeter. So I always did the best I could with what I had, but this here should make things a lot better and be able to get readings a lot better. I mean, look at this here. It goes down, it's got a 1 volt range. So from here all the way across to here. Let me zoom in on the meter face a little bit. Yeah. I mean to jerk the camera around there. So from here to here is 1 volt, the whole scale. So we can go down here, like right there is a 1/10 of a volt, and even further down from there, and get a pretty accurate reading. And having the RF probe here, with a shielded coax all the way up to it, and with the tube in it, makes for really accurate readings when you're measuring stuff like that, especially the RF applications. So let me just show you that all you gotta do is take and unscrew this right here and very carefully slide this out, and you can see that. See if it'll focus in on that there. It's a little iMac 2-01C. Neat little tube, high frequency tube. Just put that back together. That's the main reason I want to use it, and if it turns out really accurate, I'd probably start using it all the time. I've restored several vacuum tube voltmeters, and I've done a couple on camera, and then the last one I done, this one right here, where's my pointer at? Right there. You seen the video on that one? It's pretty good. It's pretty accurate. until you get into the high ranges, I've noticed it's not exactly. And you can go in and change, with those adjustments and adjust it to get it perfect, and then it'll be off a little bit on lower ranges, and then it don't work so good in high frequency applications and stuff. So this here is supposed to be able to do that, and it's pretty accurate all the way through its ranges. Of course, if it's working properly. So the guy said this worked just fine when he got it, or the way he was using it. He said just up until then, right before I got it, he had it plugged up and using it, and said it worked fine. He said he don't know about the accuracy of it. He's had it for years and years, but not had it calibrated or really had the back off of it or anything. He said he just uses it for, as an older guy now, just kind of used it a little bit here and there for some just general low voltage checks or something like that. Something you can just grab a cheap, digital multimeter and use for. So I have to go through it and check everything out. So let's see here, before we get it on the face of it here, you got your, of course, the meter face here, indicator light, ohms adjust, so when you adjust over here for your ohms, then you got a zero adjust back here in the back. This is two knobs here. You got a knob here, turn knob here. And the knob in the back would be for your zero adjust for like your ohms or your DC. And this one, of course, it says right on there's AC 0. So even the AC for your other probe here has got its own zero adjustment. Make things that much more accurate. Then down here we got, of course, your standard off switch, DC minus, DC positive, AC ohms, for your resistance, and then your ranges here. And everything feels pretty nice and solid. And I believe the guy, I got it from, that it worked fine. But me, I don't want to plug it up until I check it. I don't know if anybody's been in. I can tell somebody's been into it if you look right here. You see this here. At some point, somebody's been into this thing and boogered that all up, and I don't know if they was changing a part in there or what, because to get into this thing you just take two screws out of the back. So, but anyway, going to the back, you see there's on the back here nothing there, but maybe use this so you can kind of see. I can stick in there, that far. There's a little latch here, or a little button you push in, a little metal button. You're supposed to stick your finger in here and pull it, and then it gives you access to the back here for your calibrations. I don't know if that's all the calibrations. They don't look like it'd be all of them, but the ones that's really important for when it's in the case. And there's a ballast tube. That's interesting. So that would be 6-4. That's probably to maintain a constant current, everything, regulation for this tube here. It's kind of like an AC regulator. Of course, you get to your fuse there, but that's that. So let me slide this off of here, get those screws out, and open it up, and we'll take a look on the inside of it. So to get this thing apart, you take these two screws out of the back here, which I've got took out very carefully. I want to set it on the edge of the desk here so that you can't see it on camera, but it's not pinched up against the top. And you just kind of work this thing, and you can see what I'm doing here, and it just lifts out like that. So let me get that lifted out of there and get this case off of here and out of the way, and we'll have a look at the inside. Okay, we're on the inside here. I'll start on this side here, and you got your two tubes here, and it's nice they've got them labeled here. They're both 12AU7s, So we'll look at the schematic in a minute, but of course one of those will most likely be in the bridge circuit. And then you got a capacitor here that'll have to be changed out, because I want to use this thing. I want it to be reliable, and that may test out good, but then tomorrow it may go out and take out the transformer. So, and I definitely, that's a nice, look how pretty that transformer is there for some, that's just surface dust. This has been taken care of, in a good environment. This dust aren't gonna be much to clean up this thing. Change that out. Check the tubes. All these are Allen Bradley style, so they're probably good, but so we'll see how it goes when we fire it up, and if we have to, we'll change them out. Hopefully it'll be a nice, easy get it going. And now you can see closer to all your connections here, or your your alignment. This one here's got one of those, you gotta loosen this off, kind of like a vise, on a drill. It's got 3 fingers that kind of pinch it in. You gotta loosen that off to adjust that and tighten it back down. So there's those, and there's that ballast tube. We'll look at the schematic here in a minute, but hopefully that's still good. It's got looks like a filament in there. Let's look at that a little bit closer. Yeah, it's dusty. You can see there's a filament in there, but it's made out of something like steel or something. I think it's steel. And then some kind of a gas is put in there. And mainly, these, if anything, you just barely see a little bit of a glow on that. You won't see it glowing bright like a light bulb, or glowing, brighter, like a tube or anything. So if it's doing that, something's drawing too much current somewhere, and you shut it off and check stuff. You can still get those tubes, but try to save them if we can. Here, I can tell by looking at that is a regulator tube. Oh yeah, it says right there OB2. So that's 0, not O, I'm saying O, but it's 0 B2. Of course, no filament voltage. And I'm trying to remember, I think it's 105 volts. 105 volt regulator. And 6x4, so there's your rectifier. Come out of here, rectify it, feed the rest of the circuit. So we just got 1, 2, 3, 4 tubes, your ballast tube, and this here will have to be changed out. What I'll probably do, I've got room back here. You can see I got room, so I'll probably just cut it loose, stick a capacitor in there. What is this? 4 microfarad. I'll probably stick a 8 or a 10 in. That'll be good. Be fine for this circuit. You don't want to go too, much higher than that. That'll be just fine. So let's see what else we got here. Okay, here's some more adjustments here. Okay, let's see. So we got some more adjustments here, and they're labeled, which is nice. 30 volt AC range calibration, 100 volt and 300 volt. Now this will go up to 300 volts AC and 1000 volts DC. If you just use the probe that come with it. If you want to go higher than that, you get one of those capacitive probes, for AC or whatever, or a divider probe. It's got the voltage divider in it. Of course, you can make your own too if you're careful, but yeah, everything, it looks good and clean in here. Nothing looks burnt or anything, or so that's, hopefully this thing does work good. That'll be the thing. It may fire right up and work, but you know how good's the calibration gonna be. Let's turn it here and look. Oh, well, that's gotta go. That's a selenium rectifier, and I think you've seen me change out 2 or 3 of those before on the channel. That'll have to go. It's not a matter of if it'll go, but when it'll go. This one here is probably in the circuit for the, what you would, a lot of people call now, battery eliminators. You see there's no batteries in this for the resistance readings. So this has got low voltage on it. So it probably lasts a little longer than most of them will. But just in case, it's got to go. I got to get rid of that. Come up with something there. Replace this here. And while I'm on this, I want to mention, I see people constantly, talk to them. I see a lot on these forums. Of course, you see everything on the internet, but if you see a selenium rectifier, just change it out with a modern, silicon diode. You're fine. No modifications needed. A lot of people's like, whoa, no, you can't do that. You've got to put in a series drop-in resistor, because this has got a different voltage drop, than a silicon diode. So you got to do that. You can't not do that. You'll burn something up, and then it's back and forth. These people, and it's just, you shake your head when you watch, listen to all that. And some of these people, you can tell that know what they're doing. Some of them, they're just kind of going along with the flow, what somebody else told them, and it's just like, these here, some circuits, yeah, you're fine changing it out with the diode, regular, like a 1M4007 or something like that. Change it out, direct swap out, and you're fine. You can go with it. Some cases you need to add a drop-in resistor to match the voltage up. Depends on the circuit and what the device is that you're changing it out in. In this, it's a piece of test equipment. I want everything as accurate and as close to factory as I can, because I'm measuring stuff with it, especially with the resistance. So yes, we want to change this out and put a drop-in resistor in if it needs it. Now, some of these already got a drop-in resistor in there, and it may, have one, may just have to change the value of it, and we'll see. But this, yeah, definitely you want to put a drop-in resistor in there. So, and this here, you can take these screws out, and this will like wiggle out. It's got pins that push up in there. You can take this off if you wanted to. I notice this coax has got a little bit of a break here in the thing. That's another thing too. This DC probe, and you see how much fatter the cable is. This is your ground, common ground. And here's this red one's your resistance. Your ohms. And of course, we'll talk about the other one, but this one here is for DC measurement, and it's got a piece of coax that goes all the way up to right there, or pretty close. It probably should be a resistor in here, but it goes right on up to there, shielded, so that makes it really nice too. But I notice there's like a break there, but that's just the outer. I can see the braid in there. As long as this is still, and the braid and everything's intact, this will probably be just fine. At least for a while. I'll see. I may have to. But you can just take these screws out, slide this off, and I could take this probe head here, get some more coax, change it out, and go with it. Yeah, it's got the number on it. It's Belden 8410. So, find something equivalent to that. Can't get Belden 8410, and that's nice and fresh, and replace it. And here's your precision resistors. on your switch. You can see there's some back in here a little bit further, but this rotary switch you can see here. So let's hope those are good, because that'll definitely mess the accuracy up. If not, you know, you can't just take these and say, I'd like to buy one of these, please. On DigiKey or Mauser or something like that, like this one says, what does that say? 46.74 mega ohms. You know, you don't just, that's not common. This one 21.63 mega ohms, and they're all 1% tolerance. So if these are out of tolerance or go bad for whatever reason, you'll have to make your own resistor up. I mean, there's places that will custom make them, but it's way cheaper to just make your own. Just get some 1% tolerance resistors and series and parallel them up till you get, you know, this value, because having them made, unless you're going to need, you know, 1,000 of them for a run or something, you're just it's just crazy. So, but anyway, so let me get this thing, get this capacitor changed out here, get this changed out here, and then we have to check the voltage on it and go from there. And we'll fire this thing up. Let's have a real quick look at this schematic here. So you got your power coming in through a fuse, and there's your transformers. Got two primaries, so we can parallel them or series them up, depending on if it's 240 or 120, or, you know, 230, 115. That's another thing too, since we're using, it's about 120, 121 here, not 115. Oh, I bet you there's going to be, yep, right here. Here's your selenium rectifier, there's your drop-in resistor, and yep, it's got a, so we might get away with it, but we're still probably going to have, I may have to change this to a different value, but might be able to get away with adjusting it here, because if this gets plugged into something that's 110 volts, say back in the day, you know, that's going to throw off your readings a little bit, you know, on this here circuit. Now the other circuit's got like the regulator in it. You got this regulator here that goes down and across, you know, that's just for set stops right there. You get your voltage feeding through here, and this, it's got an adjustment, but there's your heater for V1, which is the tube and the probe. Then you come on off over here and you go through here, and this should go, yep, you see it goes up to your bridge up there for your resistance. So pretty standard schematic. Your heaters, there's your 6x4. You got your high voltage coming off here, 165, going to, here's your bridge, your 12AU7, and then here's your there's showing a picture of that tube and the probe, and your ohms are coming out here, see, and tying into this, your divider for this, and then that would feed in to the bridge. And you have on the other side, yeah, here's your zero adjust for your ohms and DC. There's your DC, yep, see it's over here, ohms and DC coming through here. Where is, okay, I was just looking at the, here's your zero adjust for your AC right here. So we're coming through here. That's in reverse. Okay, so we got negative voltage here, yeah. And I'll have to look that up. I thought it would show voltage like 105 or something. Let's see. Okay, we got a resistor here. Okay, I've looked that up. I think that's 105 at 0B2 105 volt regulator. But there you go. There's your mirror movement over here. So yeah, let me get this couple of parts changed out here and we'll fire it up and see how accurate it is. Don't know when last time it was aligned, if it ever was aligned, or whatever. So of course I meant ever since it left the factory, if it had realignment. So well, I just noticed one thing here. This is a Telefunken tube. This is a different one, so definitely somebody's been in here. I don't know what. I guess they took the other screw and boogered it up over here. See that? That screw would come in through here. There's a screw and takes this section out. And I don't see right away, but I'll see as I get into evidence anybody changed anything out. They may have thought you had to take those screws out to, get into it. And that's the reason. But those two tubes have been changed out. They're not, because factory would be HP. Back in this time period, it'll say they'll have special made with HP. Yeah, right here, just like this. I'll get this regulator tube here, so if you can see that. It says it right there, HP, Hewlett Packard, made in the USA for HP Hewlett Packard by RCA. So it would, all the tubes in it would say all the tubes but this ballast tube. I've seen inside these before, and they always have an Amperex ballast tube in them. And I don't know if maybe RCA don't make these or what. Or I don't know what the what it was the end reason, but it was always Amperex. But everything else would be HP, and this one's only got 1 HP left in it. Looks like. Nope, the rectifier tube's HP too. These two down here are still HP, and these two here's been changed out, which where is it? V3 here usually sees the most action going on in the bridge. Really, if you're going to do it right, you need to get one of these that's got a matched, this has got 2 triodes in it, so get a matched set of triodes, for it to be perfect. Of course, that's why you get adjustments for and all that. But anyway, get that done, and we'll be back with part 2 and go through in the alignment and fire it up and have a look at it and all that stuff. So hope you've enjoyed this video on going through initially on the HP 410B, and I'll catch you in part 2. This is Michael, KE4EST 73.